When an object the size of a small mountain comes racing into our solar system from interstellar space, scientists notice. And when that object begins to accelerate in ways gravity alone can't explain, everyone starts asking the same question. What exactly is 3I Atlas doing out there? At first, astronomers thought it was just another comet, a frozen traveler from the outer reaches of the galaxy passing by our sun before vanishing again into the darkness. But what they've observed since its perihelion on October 29, 2025, has changed everything. 3I Atlas isn't behaving like a comet at all. It's showing non-gravitational acceleration, meaning it's moving faster and changing course in ways that simple physics can't explain. NASA's Jet Propulsion Laboratory noticed it first. Their tracking data showed that 3I Atlas had drifted 4 arcseconds from where gravity alone said it should be. That might not sound like much, but when you're watching an object 203 million kilometers from the sun, that's a staggering 80,000 kilometer deviation. Something, or someone, is pushing it. The acceleration itself is tiny, about 0.02 millimeters per second squared. But over time, that tiny push adds up. Every day, it's moving 135 kilometers farther from the sun and another 60 kilometers sideways. That means it's not just drifting away, it's veering off course in 2 directions, as if guided by some invisible force. Harvard astronomer Avi Loeb, who famously suggested that Oumuamua might be artificial, ran the numbers. If this acceleration came from normal cometary activity, ice turning to gas and venting like rocket thrusters, 3I Atlas would have to lose 1/6 of its entire mass in a month. That's around 5.5 billion tons of gas. And that kind of activity would make it spectacularly bright, with a massive visible gas cloud. But so far, telescopes haven't seen anything close to that. The Hubble and James Webb telescopes are both preparing for direct observation in December 2025, when 3I Atlas will make its closest approach to Earth, 167 million miles away. If that cloud appears, we'll know it's just an unusually active comet. But if it doesn't, we'll have to face something far stranger. The possibility that this interstellar object is using some kind of non-natural propulsion. It's not the first time we faced this mystery. Back in 2017, the first interstellar visitor ever detected, Oumuamua, showed the same behavior, speeding up as it left the solar system with no visible tail or outgassing. Scientists called it a dark comet, though even that term doesn't make sense. A comet without gas or dust isn't really a comet at all. 3I Atlas, however, makes Oumuamua look small and simple. This object is massive, at least 33 billion tons, somewhere between 1,000 and 1,000,000 times more massive than either Oumuamua or Borisov. The second interstellar visitor, its core is thought to be nearly 6 kilometers across, roughly the size of Mount Everest sliced in half. But mass isn't the only oddity. As 3I Atlas approached the sun, its brightness shot up faster than any comet ever recorded. Normally, comets brighten according to a power law of -2 or -3. 3I Atlas's brightness increased with an exponent of -7.5, more than double what we'd expect. It was glowing far too fast, far too bright for any normal icy body. And then there's the color. At its closest point to the sun, 3I Atlas appeared bluer than the sun itself. That shouldn't be possible. Dust and gas usually scatter red light, not blue, and cold surfaces, like the icy crust of a comet, glow in reddish tones, not bright blue. To see an object colder than the sun glowing blue suggests something exotic, possibly ionized gases or artificial reflectivity. Some scientists argue it's caused by carbon dioxide or nitrogen ions excited by solar radiation. Others, like Loeb, point out that those explanations don't match the observed brightness curve or spectral readings. Whatever is reflecting that light isn't behaving like frozen rock or ice. That's why this event has become so controversial. Some astrophysicists think 3I Atlas might be a piece of interstellar debris from a destroyed exoplanetary system. Others think it could be a fragment of something artificial, perhaps a probe or solar sail launched millions of years ago by a distant civilization. It's important to note no one is jumping straight to aliens. The debate is about method. Science isn't about what we want to be true, it's about what the data allows. And right now, the data doesn't fit any existing theory. Ignoring that isn't science, it's denial.
Loeb has said it best. When you have data that doesn't fit your models, you don't throw out the data, you expand the models. The universe doesn't owe us easy explanations. As December approaches, dozens of observatories, from the European Space Agency's JUICE spacecraft to NASA's Deep Space Tracking Arrays, are preparing for coordinated monitoring. The International Asteroid Warning Network is also tracking it closely, not because it's dangerous to Earth, but because it's unpredictable. If the outgassing cloud doesn't appear, 3I Atlas would officially join a tiny group of objects known as dark comets. As of December 2024, only 14 of these have ever been confirmed. They look like comets, follow comet-like paths, but produce no visible emissions. Scientists don't fully understand them, and 3I Atlas is by far the largest and most extreme example. Some have even noted a faint antitail, a feature where dust or light appears to point toward the sun rather than away. That's a strange optical phenomenon usually caused by large coherent dust structures or electromagnetic interactions. But in the case of 3I Atlas, the geometry doesn't quite fit. If verified, it could indicate structured or directional emissions, something you wouldn't expect from a natural comet nucleus. And then there's the composition issue. Early spectroscopy hints at unusually low water content and a high ratio of nickel and iron. That suggests a body more metallic than icy, which again goes against everything we expect from a comet. An interstellar object accelerating without jets or outgassing is an astrophysical riddle. By early 2026, 3I Atlas will cross paths with Jupiter's orbit. Gravitational interactions with the gas giant could alter its trajectory, giving us a final chance to observe how its motion changes under intense forces. If its acceleration remains inconsistent with natural physics, that will be hard to ignore. Of course, the alien hypothesis always draws attention. It's the boldest explanation, but it's not the only one. Some suggest 3I Atlas could be a fragment of an interstellar asteroid that shattered long ago. The asymmetrical shape and rotation could cause reflected sunlight to create a small radiation pressure, mimicking propulsion. Others point to exotic physics, maybe sublimation of supervolatiles like nitrogen or carbon monoxide, something rare but not impossible. Still, none of these fully explain the brightness, the blue color, or the dual-direction acceleration. If this were a natural comet, it would have to behave in ways never seen before, losing mass faster than any known comet, yet without releasing visible dust or gas. That contradiction alone keeps scientists awake at night. Think about what this means. If 3I Atlas is artificial, it would be the first confirmed technological artifact from beyond our solar system, a relic, maybe even a probe from a civilization that existed before humanity ever looked up at the stars. It could be ancient, inert, drifting endlessly between star systems until chance brought us close to it. Or it could still be active, powered by mechanisms we don't yet understand. Either way, it challenges our understanding of how the universe works and our place in it. Every strange observation forces scientists to reconsider what's possible. Just like Oumuamua did in 2017, 3I Atlas is a reminder that discovery isn't comfortable. It's messy, uncertain, and deeply human. So, over the next few months, the world will be watching. Ground telescopes, orbital sensors, even amateur astronomers will turn their lenses toward the deep sky, waiting for signs of a glowing cloud, a sudden burst of light, or something even more mysterious. If 3I Atlas turns out to be natural, we'll have learned something profound about the physics of interstellar objects, how they move, how they survive, and what they're made of. But if it's not natural, then this moment will mark one of the greatest turning points in human history. Either way, this story isn't over. 3I Atlas is still out there, gliding silently through the inner solar system, defying our equations, and daring us to ask questions bigger than ourselves. Because, somewhere out there, In the dark, between what we know and what we don't, the truth is waiting.